2016. We will talk about Dash standardization, adoption by Consortia, and deployment, the latest news. And I would first like to introduce the panel. If each panelist introduce themselves and what do they do, I will appreciate. Starting from Alex.
Okay, so I'm Alex Gilady. Is the mic on?
Yes.
Okay, so I'm Alex Gilady. I'm principal architect at Comcast, and I'm also a long-time participant in Dash standardization as contributor and spec editor.
Hey everyone, my name is Deepak Das. I head up marketing at Visualon, and we're a cross-platform media player provider and member of Dash supporting the Dash IF.
I'm Robin Wilson from Negra, a DRM, conditional access security company. My background's in video, all sorts, from a lot of background in compression and more recently in security.
I'm Raj Nair. I'm with Ericsson. We've been supporters of Dash for a while. We've been also founders of the Dash industry forum, and we've been building a variety of video products. So my role is in strategy for TV and media in Ericsson.
Thank you very much. I'm also Iraj Sodagar, multimedia architect at Microsoft. I'm president of Dash IF, also chairing Impact Dash standardization in ISO. The format of this session today is that each panelist talks 8 minutes or less, and then we spend 20 minutes on Q&A with the audience. Let me start just to give you an update what's going on in the terms of standardization, what's new. Last year I showed this diagram, a similar diagram. Now it has few new blobs, it has few new checks, but in summary, the Dash specification originally published in 2012, the second edition 2014. Last year I talked about Amendment 1, Amendment 2. We were working on Amendment 3 that has several tools. That one has finished. And now we are working on Amendment 4, maybe talking about a bit of the tools there. In Amendment 3, we have a method of signaling authentications or authorization control in Dash manifest. We have a new method of anchoring MPD play at a certain point of MPD for live content. Now you can basically signal based on the wall clock time, the actual real clock, if there is a live content, where to start to play. Callback event is a method for reporting back what player is doing in terms of the playback, can be used for collecting information about the player and whether the user has played certain part of the content, good for instance, ads. External MPD linking is a mechanism to basically create a composites of different channels and be able to link it to the individual channel. This was brought by 3GPP, has other uses. Period continuity is another tool that if you have the same content and it's spliced in different periods, basically the player can detect using the signaling here that this is the same content. So in terms of the playback, it's ease up playback for the player, doesn't need to do reinitializations of the decoders. So that's Amendment 3, which is done technically and is going for publication. Amendment 4 has a broadcast TV profile. This is done in the light of, as I will talk, and some people talk here about ATS C201, defines a more flexible segment formats that allows that be able to do a streaming, but at the same time use the same content for broadcast. It enables fast channel change, fast channel startup. MPD chaining is a method to support pre-roll ads for the live content. So you be using this. Basically, you can connect two MPDs with each other. Any client joining at any time. First of all, it can has its customs ad, and then you don't need basically create a special content depending on the client or depend on the join time. The same basically manifest can be served for pre-roll ads for the live content. And MPD reset is yet another tool to improve streaming for the live content when there is a discontinuity, losing, say, an update in MPD. You signal the client, this is the continuations, just reset. You don't need to have the continuous MPD update and start from this MPD. So as you can see, new tools are being added to the standard. There will be a third edition that consists of second editions plus these 4 amendments. And that's the core specification. Last year, we talked about server and network assisted dash. We were developing that one. This is gone to a draft international standard. I think Raj is going to talk about some of the examples, but this is exciting in the sense that it uses information out of band provided by the client, given the status of the network, and the client further can optimize streaming. Something very new. It hasn't done before in any of the streaming protocols before. The new part 6, dash with server, push, and WebSockets, is basically designing or improving dash for using with protocols like HTTP2 and WebSockets that have a push channel. This allows to further reduce the latency on the live streaming. And that's just went to the committee draft and is going through the standardization process. There are other components on the standards being developed. In Dash Industry Forum, again, I show a similar slide, but if you compare this one with the last year, you can see a lot of stuff have moved to the left. Of course, the missions of the Dash Industry Forum is interoperability. It's to provide implementation guideline, test tools, conformance software, reference players for the members and for the public to implement either the client or encoders or services that works with each other. That helps a lot in terms of deployment. Recently, we published Dash IF Interoperability 3.2. As you can see, it has several features, live services, ad insertions. We added 2 new audio codec, AC4 from Dolby and MPEG-H audio. It has support. It basically shows how to do a streaming using HTTPS, supports key rotation and cross-adaptation sets. The value of an implementation guideline is that tells you exactly, as a content provider or as a player, what you need to do in order to be able to provide the content or play back the content on the device. Conformance and test suites for Dash IOP 3.2 is being worked on. There is a Dash.js player. I think lots of people are familiar with that, the JavaScript player that uses EME and MSE to play back Dash on any browser environment. That gone through a major refactoring from version 1 to version 2. Now we are in version 2.1. It reduces basically the size of the code, as well as it has some new features. Some of the features are in 3.2, the IOP 3.2. The idea is that eventually Dash.js supports everything that we have or in implementation guideline. It's a reference player, and in many cases, people even use it as a production player. If you look at other activities here in the middle, shaded with yellow, ATSC 3.0, Dash IF is in collaborations with ATSC, creating a Dash profile for ATSC 3.0. Again, I think Deepak going to talk about that. Some of the new tools in Amendment 4 of the MPEG is being used there. Next generation audio, which is object-based audio, is being used there. as well as scalability and app-based X-Link. There is a multi-track work, there is a UHD, HDR work is being done there, and there are several other items in terms of metrics, SANs, MPD chaining being worked on in. Again, the point is that -IF is providing more tools for doing interoperability, for early deployment, easy deployment, and for cross-check between different implementations. One more item I will talk about shortly. This is a new activity in Impact Common Media Format or Common Media Application Format. The idea here is that if you look at any streaming protocols, whether standard or non-standard, it has basically two components: media formats, manifest. You can say that it has two functionalities: media format encoding, and then delivery, that which consists of the manifest and the protocol. So the idea is that can we create a specification, a media format in the specification that goes beyond Dash. It can be used for Dash, but say HLS, Smooth, and other streaming protocols use that. This is a way to bridge the gap between different streaming protocol. Today, I think everybody has probably needs, in terms of deployments, to support HLS. Dash is basically becoming the consolidating format for all others. And now CMAF, it creates the gap, at least in terms of the encoding, in terms of the media format. Then the difference would be based on HLS delivery, and Dash delivery would be the manifest, M3U8 based on MPD. So you can consider CMAF as an encoding format that it's very much constrained in terms of, because it wants to reach the achieve higher interoperability, most number of devices in the market, and that it can be used with other manifest format. This is just started in Impact. It has the first working draft. It's going hopefully to CD in 2 weeks, the committee draft, and maybe by the end of the year, early next year, basically this comes out. I see a lot of excitement in terms of implementations of this format. So with this, I pass it to Alex. You can sit, talk there, or walk, whatever you're comfortable with.
Well, probably this is more comfortable, and thank you for having me here. What I'm going to talk about is less forward-looking. This is more about using what we have right now for a large-scale linear distribution project, and why Dash actually makes sense there as it is right now. So a little bit about the scale and the use case. So we have about 13,000 channels nationwide, and we have millions of viewers. And we want to bring television over IP to them, and where our vision is to bring this using Dash. So what have we done? We basically have Dash end-to-end with Dash-based common interchange format that is going throughout the packager and the recorder system. And then we have just-in-time packager that will output Dash, and right now outputs HLS, generating HLS out of Dash manifest. Basically just because Dash manifest is much richer than anything else, and it's very easy to generate things out of it. So in terms of requirements, so we do need best user experience, which means we need to put every single bit we have to use in terms of video quality. We need very high reliability, and we have several things that we need to carry, like accessibility related items, second language. We have also alternative content, which is something not everybody needs. So this is both advanced advertisement and blackouts, which is when you have, for instance, certain games excluded from certain markets. And as I said, the solution we ended up with is Dash end-to-end, and here are some of the reasons why. First of all, more at the hand-waving level, what are the advantages of using this whole ecosystem? All of them are pretty familiar, but for instance, you cannot overstate the importance of openness, extensibility, and due process. So as Iraj said, we know exactly what is going to happen and what is going to come into the standard within the nearest year. We also know how to make sure that use cases that are important to us are addressed there and are included. And again, there were several large improvements that were made over the years that addressed the use cases for cable and broadcast. Common encryption is a huge thing for us, and good HTML integration is also extremely important. Most probably, a browser is going to be, for all practical purposes, the next setup box, and W3C support for it in case of Dash segments is pretty good. Now, diving far more technically into details. One thing that we absolutely have to have for providing both linear and CDVR is low latency and synchronization. So synchronization, imagine you are walking into a sports bar and you see several televisions showing the same game. You cannot have 3 televisions being out of sync by several seconds. This is awful user experience. So Dash is unique in terms of providing us tools for precise synchronization. So you know exactly where the live point is. You know at which point you need to request the segment so that you will get it at its earliest time. So this is invaluable for us. The next thing is latency. HLS and typical adaptive streaming deployments, they're okay with 30 seconds and with 10-second segments. Unfortunately, we cannot do this because of mainly because of ad insertion. You don't know 10 seconds ahead of time that an ad is coming. So what we need is 2 seconds. 2 seconds, if you do this with HLS, has a huge traffic overhead. First of all, the way HLS works, it requests an M3U8 for every segment. This means every 2 seconds we have a request for a listing of segments. Now, if you go into a case where you are doing the recording, you end up with pretty large manifests. So I played with the numbers recently, and what I got, a complete HLS manifest, all variants, ended up being 2.8 megabytes for a 90-minute asset. And if we use tools that are provided by Dash, like templates, we can reduce this to 6 kilobytes, basically without anything overly smart, just by templating things instead of listing them explicitly. The next pretty important optimization is you can trigger a manifest fetches as opposed to fetching every 2 seconds. So let's say if you have 15-minute main content and then you have an ad break, in HLS you would have been requesting everything every 2 seconds. We can do a single request at the end of the 15 minutes to get the ad decision. Nothing changes in the middle. You are still downloading segments from the same source, and you are just predicting their URLs and their availability. Last but not the least, reliability. Right now, we already have pretty good behavior in terms of multiple sources for a single segment, which allows us to fail seamlessly, and MPD updates, which basically let us update and accommodate for failures. And then the new 3rd edition contains even better tools for this. Now, another 2 points. One, we have period structure, which is a playlist of content, not a playlist of segments. So the good thing about it is manifest manipulation. You don't do decision per segment. You do decision per piece of content. Much lighter on manifest manipulators. And support for non-multiplexed content. we have a problem carrying several different audio tracks and several languages, and it just takes too much space. So we need to move to the multiplexed, and HLS has this for a while, but it proved to be extremely painful to go and actually implement it in live. So Dash provides a much better support here. So summarizing the talk, so I see Dash as something that works very well for Comcast use cases. We are very active in different industry initiatives and standardization bodies. So we're in MPEG, we're in SCT, which is the standardization body for the cable industry. We're in W3C. We recently joined Dash-IF and the new CTA Wave project that is hopefully going to provide a standardized runtime environment for HTML5 based streaming. Okay, so thanks a lot.
Thank you, Alex.
Hey everyone, my name is Deepak Das and I'm with Visualon. We're a software multimedia framework company, and I'm going to give you a perspective of what we see from a Dash implementation as it relates to the real world deployments, right? And what are the challenges that our customers are facing and so on. So I'm quickly going to jump over this slide because I just introduced myself and what our company does. So from our customers' perspective, this is what they see, right? There's no clear separation between reaching a traditional TV, internet, or mobile video, right? So OTT services they need to get to any and every potential device at any location wherever the customers are. This is the challenge that they face. So for them, the realities of getting to every device, every place are fraught with device fragmentation as well as service fragmentation. So we can sit and talk about all these advancements and so on, but they face a challenge day in and day out. So let's talk about, from an OTT operator, what do they see, right? The challenges. Content rights and access, most expensive. That is something that they have to deal with, and that is something that we cannot address. But from a device reach perspective, that is something we do address from a player side as well as a streaming protocol perspective in terms of Dash. The other two challenges are subscriber base, especially subscribers coming with those different devices. And one of the other challenges is existing business relationships. Very hard for them to organically develop a relationship from a business perspective with the customer to exchange their credit card information and then go on a monthly subscription to be able to sustain that relationship. Dash is helping out in terms of device reach and especially in terms of subscriber base. They don't have to worry about it from a device perspective, especially if they're bringing different devices with different DRMs and walled garden approaches of the different device manufacturers. Device manufacturers don't care about content providers or content rights or content producers' requirements of reaching all devices. They just care about how they can get all the content onto their devices, and they don't care about the other devices. But Dash, from a streaming protocol perspective, opens this up and provides this advantage for the content providers to be able to deploy across all platforms. Now, let's take the other side, challenges of a media planner, right? I mean, there's a lot of money that goes into saying, okay, how do we justify spending all this money into deploying across all these platforms? Who's going to watch this? Where's my money going to be spent? Am I going to be able to track all these devices and so on? So this is the other headache. So there's service fragmentation. They have to reach TV sets. They have to reach devices over the internet, Wi-Fi, or whatever the means of reaching that device. Screen fragmentation. As of last count, apparently the average devices per person that they view content on is about 4. So you need to track which device they're coming from, where they're watching it, how many minutes are they watching it, and so on. Let's look at the data that's coming in from a tracking perspective. There's all these different devices and all these fragmentation in terms of technology of reaching those device endpoints. So from a money spent perspective, this is all the amount of tracking that they have to do. So if you look at what's important, it's like ad insertion, analytics, security, tracking, and discovery across all the devices, across all these service sectors, right? So, as Iraj pointed out, Dash is slowly extending coverage into these areas to be able to get you that information back from all these device endpoints. So it's kind of a no-brainer because Dash helps you sort of unify that deployment and bring back all the data to your back end. Quickly wanted to touch upon ATSC 3.0. This is a move to drive commonality between delivery over broadcast and delivery over broadband, so that the stack is kind of unified, and then you're able to have a common deployment method in terms of reaching out to all your device endpoints. If you look at one of the important things that's being considered is the streaming protocol in the management stack or the application layer there. So it's MPEG Dash. We've had conversations with the team, and they wanted to know about whether they could incorporate a software codecs, expansion, using newer forms of codecs, and being able to sort of sustain that and grow on the number of codecs or protocols and so on. So this does give us that advantage to be able to deploy and then be able to slowly expand as well. So ATSC 3.0 is sort of important, and from a player perspective, we will definitely support it. From a media player perspective, it's important that we support all the protocols that are required as part of our customer requirements, but also all the requirements in terms of what they need in terms of deploying their services to be appropriately capture all the user information as well as deliver in a manner that's scalable and provide all the provide good quality service to their end customers. From a percentage deployment perspective, today we still see a significant portion of it being HLS, because that's the first go-to thing that most people do, but Dash is an afterthought, but Dash is slowly gaining steam. There's about 10% of the deployments from what we see in terms of Dash adoption. One of the biggest deployers in Dash in this space is Amazon for us, Fire TV and the Amazon Instant app as they call it, because they have put together an ecosystem that helps their end users basically get the best in terms of being able to support their other content providers who are going to come in and deploy their services on the device. So Dash does require some help and in terms of being able to support other people to be able to come and deploy on their ecosystem, and they've done a marvelous job of doing that. But we do see significant traction in terms of customer ask for Dash deployments, and we think that the market is slowly shifting towards more and more Dash deployments. There is definitely an ask, and then there's definitely a move from just testing to a production deployment. Thanks.
Thank you. Robin?
Thank you. Okay, so thank you. What I didn't mention earlier is Negra is a Swiss-based company, which perhaps puts us in a better position than some to chair the DRM or the security subgroup, which is in the garage here. So we have a guy called Laurent Perron who's doing a lot of hard work in that area. And actually, I haven't got a slide on this, and coincidentally, we also are, I guess sponsoring is the right word, the chair of the ATSC security group. We did have a meeting recently at NAB where we discovered some, let's say, misassumptions on either side of the interface of what each other can do for each other, which has to be resolved in terms of latency issues. There's some significant challenges in license delivery as well as the compression areas. So that's work in progress and recent and useful discovery. And that's been worked on. I don't have a slide on that. Okay, so as I mentioned, we're from a security, so I'm going to mention sort of a high level conceptual discussion here. So common encryption, I think, is the favorite term inside of Dash, but it's an old term, and I'll get into what that means in a minute. But it's tightly linked to something called multi-DRM, which in turn also is somewhat linked to the encrypted media extensions part of browsers, which allows multiple browsers to run each different DRMs. So we'll talk a little bit about some of those challenges here. So common encryption, it's also got a few other names, slightly different contextually defined names, but they're basically all the same. Key sharing. Simulcrypt is the old version of what was done 20 odd years ago for conditional access, but it's essentially the same exact technique where you come up with a common cipher and a common key length, and you avoid having to replicate streams, which can be incredibly expensive. You have to duplicate files or streams once or twice or multiple times. It's horribly expensive. So that is work that, you need the foundations for that. The DRM group alone can't fix that. You need the formats of video to be locked down or reasonably locked down, and the chunk sizes and the length of the bytes to be encrypted, to be standardized. So that was all done ahead of time, which helps. Now, multi-DRM feeds off of that. That allows you to run multiple DRM servers on the same content. And a lot of this work in common encryption, almost all of it is in the head end of the server, and it makes life a lot easier in deployments. In the old days, and even now still, unfortunately, there's a lot of custom interfaces still done, quite a bit an expense running multiple DRM servers together. It's gradually getting a lot better. Dash will and has actually made that much easier off the shelf in many cases to run multiple DRM systems, at least in the head end. But multi-DRM is an interesting technique. It's a problem and a solution at the same time. Oh, did I just, something jumped there? Must be static, sorry. Okay, here we go. Yeah, so we come up with another solution to a problem here, which is encrypted media extensions, which is, I think somebody mentioned already, Alex and Raj, is a part of WC3 and browsers. It also allows us other parts of that work that allow Dash content to seamlessly interface to an HTML5 browser. However, there is an issue which is hidden almost entirely, but are well hidden to the end user, which is currently the browsers and DRM are locked together in these combinations, and there's also on, I always forget the other browser, Firefox, yeah. It's a little more complicated in Firefox, but let's just say we've got this interesting situation here. Now, multi-DRM helps this situation, so it kind of launders the problem from the consumer side. The consumer, the viewer picks their favorite browser, or at least has some favorite browsers available, and they don't know that if they pick that browser, somewhere there's a negotiation on the head end and on the server that brings the right DRM. So you could argue that's good, but it also forces people into implementing many DRMs. If they want to get a 99.9% reach, you will have to implement at least these DRMs and probably some more. But on the other hand, we make life easy by making it seamless. So it's a double-edged challenge there. Oh, there is some definite sensitivity here, and it's not me. It's, I don't know if it's static. Let me press very slowly. Okay. So it's a bit ironical, but that's, from a DRM company, we see that a lot. If you're doing some other part of the system, you may not, although I'm talking to Deepak here at Visualon, I think they have to do multiple DRMs sometimes in the same player. So there's some challenges there. So we have to deal with that. Content protection. So let's talk about the fundamentals here, where we're going DRM, because DRM's not as old as the original security called conditional access. DRM may have some end-of-life characteristics about it too in some ways. So in the early days of TV, digital TV, the keys were pirated because the content was way too fat and big to be pirated anyway, and also it was broadcast on satellite cable and so on. So, and that form of piracy is still prevalent. It's less perhaps, but people set up key servers that spew out a few kilobits of keys, and they charge about 1/10 of what your operator might charge, and they run it in some untouchable country that used to be part of Russia. And you know, we all go after them, and they appear somewhere else. But that, thankfully, perhaps, hasn't happened with much, I guess, or at all with DRM systems. And the reason for that is time has moved on. Content compression's improved significantly by 5 or 10 times, actually, for the same resolution. And broadband speeds would be, say, 50 times faster. So it's actually much, much easier now just to put the file, the decrypted file, up. You know, a gig or two or less, if you don't mind the quality of resolution, is relatively trivial. So DRMs and that those type of hacks are after the DRM, typically on the output. So this is where focus is moving, maybe beyond DRM, tracking the content and finding out where the rogue copies are. And although it's not a specific part of Dash, Dash has to be friendly to some of these watermarking schemes in terms of there's some clever ways the CDNs have to operate on different chunks by personalizing them, doing kind of a form of Morse code on selecting different servers. So we have to look at that stuff, but also watermarking might also be a significant part in the future, and I'm not sure if there's exactly a place in Dash, but Dash has to at least keep itself clean in terms of allowing watermarking to be added and taking care of robustness rules and so on, which defines output control. Robustness also means the HDMI output has to be locked down under certain circumstances. And I see there's a touchpad I can't see in the dark, sorry.
Oh,
It's armed and dangerous. Okay, I think that might have been my last slide anyway. So it was my last slide. Anyway, thank you, everybody. Thank you very much.
Thank you. And last not least, Raj.
Thank you, Raj. So what I'm going to talk about is some of our experiences with deploying Dash, but this is in a mobile context, and so some of the work we've done is in LTE broadcast. As you can see, there have been some deployments reported, the Verizon's and in the stadiums. There's a Telstra one in Australia. So we are very big on Dash. We believe it's the way for us to unify across all the range of customers that we deal with, from wired with DSL all the way to wireless with 5G and so on, and LTE broadcast. And it makes the workflow normalization, which Alex had mentioned, simpler, and also some of the points that Deepak and Robin had mentioned about both the device normalization and the DRM normalization much easier. So for us, as a end-to-end sort of enabler for video, it makes our life much easier. So in this slide, what I'm showing is essentially, this is the standard model which most people are used to, the player pull model, which, where the player does the pulling of the MPDs, and then you get, then it goes and pulls segments, and finally, of course, that process goes on, and there are various optimizations that can be done for that. We have, for LTE broadcast, by the way, this is the 3GPP work, which was also one of, I think, I'm not sure if Iraj had in his slide, but there is another group also working on Dash in 3GPP. And so here, it is what we call a network push model, and we'll understand shortly why this is important. And so here, the idea is that the MPDs actually get pushed out, and this is again for broadcast. And then, so as you can see here, It starts off, of course, with a phone app coming up, and then there is a Dash player, which of course requests MPDs from a EBMS proxy. And then this is also sitting actually on the device, all right? So, which is sort of locally feeding this Dash player. But then the LTE broadcast is actually pushing these segments out to these proxies, which are then able to feed the player. So it is a little different model, but it works for the LTE situation. And for example, and these are some real reasons, from our trials why we need this. So first and foremost, you can see that one of the things that we found is that during the transport over these wireless networks, because they're very unpredictable in terms of bandwidth, we found that it was useful to actually do a multiplex mode during that transmission. And this is simply because the FEC that is used doesn't work well for audio segments that are very small. And so we found it better to multiplex them and send it. Some other points that we have seen is that there is some issues with the NTP server drift, which we were able to solve with configuration. But I mean, these are just specific to this use case, and it is not things can be are improving. Some other experiences we have seen is that on the satellites that sometimes we have this problem of getting the out of synchronization between the encoding and the segmenter, and so we need to have a better way to update the MPDs, and we believe doing an in-band MPD distribution would solve that. The other thing is we have found, again, this is for the LTE broadcast, where if you have the single frequency networks, there may be some delays, propagation delays between, because they're coming from different nodes. And so in this case, we need to adjust. The good thing about Dash is it has all these tools. So we have this segment, the availability start time for the MPDs, which can be used to adjust for that. So there are all these tools that can be used to configure even in more challenging conditions. And then some of the improvements that we can see can benefit is the maybe having a MD5 for the segment, so that we know that it is corrupted, because for the live it is sometimes difficult and can cause crashes on the players, and also the how you deal with the incomplete segment. So these are some, and we have some of these contributions going into the 3GPP, which of course will flow back into the other bodies. So, so I mean, that's essentially it. And I want to thank everybody. Hopefully, it was, if there's any questions, of course, we
Thank you very much.
Thank you.
Now we get to the part for questions and answers. I hope you guys have questions. Yes, please. So what's the best approach for supporting Dash in older browsers that don't support MSE EME? That's the question. Who wants to take it?
Well, plugins are, from our discussions with operators these days, plugins are considered antisocial, which is a bit of an awkward thing, but we're kind of stuck in this wonderful world that, gosh, it magically works on this browser. Why doesn't it work on this one? I'm sure that you got that challenge.
Yeah, so just to continue on that, from a content deployment perspective, if they have to put out content, and it has to reach those browsers that have no EME or the ability to support security and make it secure. There's always that the decision that they have to take whether they're going to deploy to that or they're going to deploy a plugin method, and some, depending on the workflow, some may choose to use a fallback option like you mentioned, but in most cases they look at the market and they look at the percentage of people that they think may come across with those browsers, and then they have to make a choice whether they're going to make an investment on the workflow side, whether to support a particular percentage of those users who may come with a desktop that has a particular need for that particular browser combination. So today it's a choice about making an investment from an ROI perspective and reaching and having that reach across to all devices.
Thank you. There was a question first there. Yes, please.
Yeah. So you mentioned from a DRM standpoint that on Safari you can leverage FairPlay, but does FairPlay support common encryption? Or my understanding was that Apple had announced that they were not supporting common encryption.
So the question, I just repeat for the recording, that does Safari support common encryption? It supports FairPlay, but does it support common encryption so it can added, DRM can be added to it? Anybody wants to, I guess?
Well,
Robin?
that's a level of blocking beyond what the, I mean, I mentioned the issue of the verticalization of the silos on EME. Then we get to, under that, do they support Dash or not? Or common encryption in the Dash mode, let's just be specific. I actually don't know the answer, but it actually kind of tells you a story that it's even worse than what I said, because not only do you have those silos, but you may or may not have an Apple silo as well, and I think that's a complicated work in progress.
Maybe I can add a little bit to that. Today, of course, Safari just supports FairPlay, and Apple devices, iOS, only supports HLS, which has nothing, well, it has very different to Dash, both in terms of manifest as well as the media format, MPEG-2TS versus fragmented MP4. CMAF, when I talked about common media application format, it's actually a joint activity between Microsoft, Apple, Comcast, Ericsson, maybe 20 other companies or more in Dash, trying to basically come up with a single media format. As I said, that format supports common encryption and to enable to support multi-DRM. So if any of these companies get to deploy that format, that problem hopefully gets resolved.
It still doesn't unlock the FairPlay to
Well,
Safari
there are two
directly.
parts of it. Whether the browsers, the format supports common encryptions and the browser supports common encryption. The second is that whether there is a multi-DRM implementation per browsers. Today, as Robin said, every browsers have one DRM supported. So maybe the follow-up question is that, is this a progression because they need to implement first and the second, or is this a business reason for doing that?
I want to add that we're not going to get to a perfect world in the near future, but it's definitely moving in that direction, and there are some convergence happening even in that.
I think you are doing multi-DRM.
So I'd like to call it two things: a multi-DRM with common encryption, and then maybe multiple DRM where the vendor or the content provider takes on the headache of putting it into the app layer and then trying to solve that with different streaming protocols and different DRM supported just to be able to reach those endpoint devices. It's a headache, it's a fragmentation issue, and they will solve it based on the needs, and the iOS market is huge, so they will have to end up supporting that, right?
Okay, you have a question?
Yeah, so you mentioned the broadcast TV profile and fast channel switching. Can you go into a little detail on that?
So what's the characteristics of broadcast TV profile and fast channel switching? So, I mean, other people can add to it too, but in previous or more common dash profiles for the segment format, each segment starts with a random access port or a switching port, what we call it SAP, switching access point. And inserting switching access point each segment make it difficult to have very short segments. In order to make it more broadcast friendly and be able to switch, you can separate the property of switching versus random access. Random access means that you can start the stream. For that stream, switching is just for switching from one stream to another stream for dynamic adaptation. So that profile actually separates these two properties. So now you have segments that they are switching point segments, start with the switching points, and there are segments that are just for random access. So since you have the shorter segments, as soon as you get the first random access point, you can start that channel or switch that channel. You cannot do dynamic switching for them, but meaning changing the bit rate, but you can start streaming.
And the other part that I sort of alluded to earlier is you can't just assume clear text on the broadcasters, even though it might be free, might want some form of authentication, which is encryption by another name. Therefore, we need to make sure that the license delivery mechanisms don't get in the way of this. I mean, it's quite challenging, but nonetheless, the video, neither of them can be later, so you need to make sure the license stuff is taken care of in a very short period of time, which isn't trivial.
More questions? Yes, please.
Is there any move to standardize or incorporate multicasting into the Dash standard?
So the question is that is there any move to include multicast in Dash standards or be able to deliver Dash using multicast rather than unicast?
Well, the earlier what I spoke about, with 3GPP with the LTE broadcast, that was a multicast using, there are different techniques for that. There's some using flute, and then in the, I think Cable Labs has a multicast ABR using NARM for error recovery. So these are where they multicast the segments and then use that, and in some cases even the MPDs.
Anyone? There is also an activity in DVB. It's called ABR over multicast. It's Dash and other protocols, and the purpose of that standardization, it's at the requirement level right now, is to be able to deliver the content using multicast to a home gateway, for instance, and from there, then you do unicast to the devices, not to all the way to the end device, but to an intermediate device. There are CDMs using multicast to deliver the content to the edge and then use unicast, say Dash, to streams to the basically customer devices, to the end user devices. Yes, please.
I can't remember if somebody addressed this, but does Apple plan to support Dash on OS X or iOS? Either or both?
So the question is, will Apple support Dash on iOS, the latest version of iOS or any iOS versions? Anybody wants to take that?
Probably better to ask Apple.
So they're not a member of the consortium?
No.
They are not a member of Dash Industry Forum. They are, of course, participating in MPAC, and they are one of the main contributors in common media application format standardization. Questions? Yes, please.
What are your thoughts on VP9 and Dash being official, etc.?
So the question is, what about VP9? Is there any official publications of any support of SOX for VP9 support in Dash? Question, answers?
So there is some work I know of that is going on. There was a submission on carriage of VP9 in file format, there are people who are using VP9 over WebM with Dash. One of them is Google, as far as I know. There are some other companies that are doing this. But doable.
Any questions? What time do we have? We have still a couple of minutes. So maybe I ask a provoking. Yep, there is a question. Yes, please.
What about
Bernard.
the status of the GIF project, the global internet video economy ecosystem?
The question is, what about the status of CTA GIVE project? Global internet video ecosystem?
I have no idea what.
So right now it has a slightly different name. It's now called Wave.
Oh.
And we really believe in this, in the purpose of this project. One of the good things that it can bring is a standardized runtime environment based on HTML5. So this is one of the good things that may come out of it.
Wave yet need to be defined, but it has. It seems that it has two.
Yes.
It's a basically device profile. It has two environments. One is defined the runtime environment for the app. One is will define the mandatory media components and also MSE, EME. Having that environment, then delivering media to devices that support that, it becomes much easier. You can develop your applications using the app environment like HTML5 and JavaScript. And then, of course, you know every device that supports Wave, what codecs it supports, so you know that the content is going to be played back on the. Any other questions? Okay. I would like to thank the panel for participation, and also I'd like to thank the audience for coming and listening to us. Thank you very much.
Thank you.